This will be an introduction of and demonstration of the Forrest Manufacturing Model 2054 vertical blade traveling table bandsaw. Just doing a refresh video of this. I've got older videos on this, but this is an update. So from the name, first off, we have a vertical blade bandsaw. This is a high-speed machine. We're running blade speeds about 3,000 feet per minute. The machine uses 20-inch diameter blade wheels. Blade drive motor on this is, for this application, for this customer, is a 5-horsepower motor. The traveling table portion, we build these two ways. We can build this either with a manual traverse table, basically just put a grocery cart handle on it and you push it, or like this machine, a powered table drive, variable speed powered table drive. So we have a control cabinet here. This is our basic controls all saw functions. Start, stop the blade drive motor. We have on this machine pneumatic blade tensioning, basically air pressure in place of the more common screw over spring. Pneumatic gives you a lot of advantages. We can talk about that later if you want to. But I do include with this a low air pressure switch. So if your air pressure is insufficient, you can't run the saw. I have a blade breakage detector. If you pop a blade, then the machine stops and the table stops advancing so you don't damage your workpiece. That's all controlled in this first row here. Saw start, saw stop, tension and detension controls. Also makes blade changes very easy. Pop the selector switch over to detention, blade goes slack, pull it off, swap it back out, move the switch to tension, you're good to go. And you know you're tensioning correctly because we use an air pressure regulator to control the blade tension. Then we have fault conditions, motor fault for either the blade drive motor or the table drive motor, and blade fault if any of those conditions occur. Table. So this machine has our variable speed powered traveling table. This is a continuous engagement. The drive mechanism on this machine is a tooth timing belt. The tooth timing belt works very well in the basically nasty environment of a typical shop. Dust, bandsaws are great at producing dust, so dust, debris, whatever, misalignment, they're really not terribly sensitive. Other applications that have special needs, we'll do a gear rack table drive, but mostly I prefer the belt drive. It is continuous engagement. I do offer an option with basically a clutch so you can release the table drive and move the table manually. Or on this machine, you can just pop the belt off and move the table manually. I have included here what I call a grocery cart handle. So if you disconnect the blade drive, disconnect the table drive, you can just grab a hold of the handle, push it forward, operator guard. This can be unbolted if it's in your way, but if you are using the table as a manual, I prefer you leave the guard on. This machine has a couple of interesting features. First off, it is upgraded with a 5-horsepower blade drive. The customer for this machine is cutting basically it's a graphite type material, very high density. It cuts almost like steel as far as its weight and density. Well, it feels like steel as far as the weight and density. Cutting wise, it cuts pretty easily with these machines. The only real downside to cutting graphite is the dust produced is electrically conductive. If you let it get in your motors, if you let it get in your control cabinet, that dust may short things out. In fact, it will short things out. So this machine is built, all the motors are washdown duty motors. The blade drive motor is a brake motor, by the way, so you hit the stop button, stops now. We've got it all plumbed up with liquidite conduit, or otherwise just keep the dust out. So I am going to do a little test cut for you here. Oh, we have the machine wired up here. We're not going to poke a hole in the cabinet for the incoming power. I'll leave that to the customer, put where and how they want. So we've got the power cord coming in here. That means I can't close the door properly. Test cutting. I have a sample of material here, this big black block. It is a fairly high density composite of polyethylene, expanded polyethylene beads, and expanded polypropylene beads. Polypropylene can be a challenging material because it has a relatively low melting point. I've had some bad experiences with it in the past, so I tend to be very cautious about it. For this cut, later on in these, I've got this workpiece and a couple more like it. On these workpieces, eventually we're going to make some slab cuts. So we're going to do slices off this block. The machine I have available for that only has a 62-inch long table. This is a 72-inch long workpiece. So I'm just gonna shorten this workpiece on my vertical saw so I can later cut it on a horizontal saw. That's not this video, that'll be in the future. But I want to find out how this material is gonna cut and shorten it down a bit. So again, from the saw control panel, saw start. Actually, I skipped a step. I need to lower that upper blade guide. Position of the upper blade guide and guard is adjustable with a hand crank. Idea here is twofold. First off, the portion of the blade that is not working. So you've got a working portion of the blade and a guarded portion of the blade. The portion of the blade that's not working, we have this guard over. And what I call the working portion of the blade is shortened between the upper and lower blade guide. You keep that short as you can, better quality cut. So again, and it sounds like we have a little hickey on the blade. That won't affect the cut, but you're gonna hear a little hickey. This is a blade that we've been using to set up the saw, and I think it's gotten bent, so it's got a little hickey to it. Won't affect the cutting, it's just obnoxious. Okay, I'm gonna start the table advance speed at 0, and then slowly increase the table advance speed as I see how this material is cutting. First I'll get it up to the blade. So I'm going to start off with a very, very slow cut here until I see how this is taking it. Oh, Rick, would you turn on dust collection, please? Looks like it's taking no trouble at all. Give us some speed. At the end of the cut, I can just let the table advance all the way to the end of its travel. It'll shut off automatically, but I'm not going to make you wait for that. I'll go ahead and hit the stop buttons. Taking this just fine. I'll probably do some follow-up cuts. I bet I can go faster than that, but while I'm filming the first article and I've got a good video going, I don't want to screw it up. But it's taking the material just fine, cutting great. Lovely. Would you turn the dust off, please, Rick? So the surface of this material is, well, first off, we'll check our cut. We are flat. The surface of this material, where I just cut it, is noticeably warm. So we really put some energy into this. I show evidence here of just a little bit of melting from cutting the material. Maybe I was a little too aggressive with my feed speed. And just because this side is hot and this side is not, it is bowed this way. Thermal expansion is like that. But we have a nice parallel cut. Okay. So the good news is, we got a nice new saw for this customer cutting graphite, and my saws and blades will cut this polyethylene, polypropylene material just fine. If you have any questions, like to discuss a specific application for a bandsaw, please feel free to call or email us here at Forrest Manufacturing. Thank you and have a good day.